On this Sierra, P0102 means the engine controller may be seeing a mass airflow signal that is lower than expected. The truck may idle rough, hesitate, feel down on power, or it may only show a light with limited symptoms. Broadly, the possible fault areas can include the MAF signal circuit, the ignition feed, the ground side, connector condition, the multifunction intake air sensor, or the controller's ability to read the signal. Start with the basic system checks, and if other codes are present, check what they mean first, so you are not chasing a symptom from another fault. For P0102, the key idea is a low MAF frequency signal. The controller applies 5 volts on the MAF sensor signal circuit, and the normal scan tool range shown for this parameter is 2000 to 10,000 Hz. The monitor is only meaningful once the engine is running under its enable gates: engine speed greater than 300 RPM, engine running greater than 1 second, ignition signal greater than 8 volts, and those conditions met for greater than 1 second. P0102 sets when the controller detects the MAF sensor signal is less than 850 Hz, about 1.43 grams per second, for greater than 10 seconds. Also keep in mind, internal controller or sensor damage may occur if this circuit is shorted to B+. With the ignition on, begin by checking the MAF sensor data on the scan tool. Start the engine, let it idle, use the snapshot function, then slowly bring engine speed up to 3000 RPM and back down to idle. Review the snapshot frame by frame. The MAF sensor GS parameter should change smoothly and gradually as engine speed rises and falls. If it does not move smoothly, go into circuit testing. If it does move smoothly, reproduce the operating conditions, including the captured conditions if you have them, and confirm the code does not reset. If it resets, continue into circuit testing. If it does not reset, the check is okay at that time. Before circuit testing, make sure the verification step was done. Then turn the ignition off, let all systems power down, and disconnect the harness connector at the B75C multifunction intake air sensor. First, check the ground side. Test between ground circuit terminal 7 and ground. You want less than 2 ohms. If that measurement is 2 ohms or greater, disconnect the sensor chassis ground and test the ground circuit end to end. That end-to-end ground circuit should also be less than 2 ohms. If the wire checks at less than 2 ohms, repair the open or high resistance at the chassis ground connection. If the wire itself is 2 ohms or greater end-to-end, repair the open or high resistance in the ground circuit. If the ground circuit test from terminal 7 to ground is less than 2 ohms, turn the ignition on and check the ignition feed. A test lamp should illuminate between ignition circuit terminal 5 and ground. If the lamp does not light and the fuse is good, turn the ignition off, remove the test lamp, remove the fuse for the ignition voltage circuit, and test that ignition voltage circuit end to end. The circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If it is less than 2 ohms, verify the fuse is not open and that voltage is present at the fuse. If the test lamp does not illuminate and the circuit fuse is open, turn the ignition off, remove the test lamp, and remove the fuse for the ignition voltage circuit. Test for infinite resistance between the ignition voltage circuit and ground. If it is less than infinite resistance, repair the short to ground on the circuit. If resistance is infinite, test between ignition voltage circuit terminal 5 and ground. This check should be greater than 2 ohms. If it is less than 2 ohms, repair the short to ground on the circuit. If it is greater than 2 ohms, test the components connected to that circuit and repair or replace as necessary. If the test lamp illuminates on the ignition feed check, leave the ignition on and move to the signal circuit. Test between signal circuit terminal 6 and ground. The expected range is 4.8 to 5.2 volts. If voltage is less than 4.8 volts, turn the ignition off and disconnect the harness connector at the K20 engine control module. Then test for infinite resistance between the signal circuit and ground. If resistance is less than infinite, repair the short to ground on the signal circuit. If resistance is infinite, test the signal circuit end to end. It should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, replace the K20 engine control module. If the signal circuit voltage is greater than 5.2 V, turn the ignition off. Disconnect the hardest connector at the K20 engine control module. Then turn the ignition back on. Test between the signal circuit and ground. You should see less than 1 volt. If the voltage is 1 volt or greater, repair the short to voltage on the circuit. If it is less than 1 volt, replace the K20 engine control module. If the signal circuit voltage is between 4.8 to 5.2 V, the next step depends on whether you have the EL38522A variable signal generator or an equivalent tool. If that signal generator is not available, test or replace the B75C multifunction intake air sensor. Then reproduce the operating conditions and confirm the code does not reset. If the code resets after that path, replace the K20 engine control module. If no codes reset, the check is okay. If the EL38522A variable signal generator or an equivalent is available, turn the ignition off and connect it at the intake air sensor harness connector. Connect the red lead to signal circuit terminal 6, the black leads to ground, and the battery voltage supply lead to B+. Set the generator with the signal switch to 5V, frequency switch to 5 kHz, and duty cycle switch to 50% normal. With the engine idling, the scan tool MAF sensor parameter should be between 4,950 to 5,050 Hz. If it is not in that range, replace the K20 engine control module. If it is in that range, test or replace the B75C multifunction intake air sensor. After the repair is complete, verify the repair and confirm the code stays gone. The takeaway is simple. Prove the low MAF signal first. Then separate the problem into ground, ignition feed, signal circuit, sensor response, or controller response, without skipping the verification step. For more diagnostic training, visit stepdiagnostics.com.